The periodic table also tells us a lot of information about the structure of each individual atom. When we are looking at the atomic numbers, and this is equal to the number of protons, every time you go up and over to the right through the periodic table, you're increasing one proton, which also is increasing one electron due to the positive and negative attractions of the protons and the electrons respectively. So with this, when we start to look at the electrons filling up the shells, in the first shell here, which is going to look at our first period, that we begin with one electron, two electrons in the first shell, and this is where the first shell becomes full. And then we'll start to fill up the second shell. When filling up the second shell, then we go into the second period. So then as we start to increase in the number of electrons, we get up to 8 electrons in the second shell, which fills up the second period. And then we go into the third shell, to where the third shell then will start to fill up, gets to 8 outer electrons with argon, and then we'll go into the fourth shell. So the periods do represent the number of shells each element will possess. Now, the groups will also be very important because, as we mentioned, we increase one proton every time we go across. We increase one electron. We get the first column here, which will have always one electron in the outer shell as it starts to initially fill. And then as we go to the second group, then this would be the second electron in the shell, then the third, the fourth, fifth, sixth, seventh, and then all the way up to the eighth, filling up the noble gases. So as we start to identify the number of valence electrons, all you will need to do is look at the group in which the element is located, such as here with carbon, where it is in the fourth group would tell you that there are 4 outer valence electrons, where when we look at the total number of protons for carbon as well as the electrons, there is a total of 6, but then the first 2 in the first shell, and then the first, second, third, and fourth for the total of 6 remaining in the second shell. Where, as mentioned, the periods represent the shells, the groups would represent the number of outer valence electrons initially.